Okay, number 87. So it says that the velocity of an object in meters per second is v of t is 36 minus t squared. Find the velocity and acceleration when t is equal to 3. And what can be said about the speed of the object when the velocity and acceleration have opposite signs? Okay, so we have v of t is equal to 36 minus t squared. So the acceleration is the derivative of velocity. So that would be minus 2t. Okay, so find the velocity. Velocity at 3 seconds would be 36 minus 3 squared. So 36 minus 9. So that would be 27 meters per second. Acceleration at 3 seconds would be minus 2 times 3. So that's minus 6 meters per second squared. All right, and when they have opposite signs, do you remember this from physics? It means that the object is slowing down. If they had the same signs, they would be speeding up. Okay, let's see if we can fit 88 in here. So 88, an automobile's velocity starts from rest, and that velocity is 100t over 2t plus 15. Find the acceleration, and there's 3 different times. So acceleration is the derivative of velocity. So let's do the quotient rule. It's the bottom, 2t plus 15, times the derivative of the top, 100, minus the top, 100t, times the derivative of the bottom, which would be 2, all over 2t plus 15 squared. So part A is we want to find the acceleration at 5 seconds. So we're going to plug in 5. So that's 2 times 5 plus 15 times 100 minus 100 times 5 times 2 all over 2 times 5 plus 15 all squared. So that's a lot to put in your calculator, but if you do it right, you'll have 2.4 feet per second squared. And then for part B, you would plug in 10. So put a 10 instead of a 5 in all those spots, and that's going to be 1.22 feet per second squared. And then part C is we're going to plug in 20. So A of 20, plug 20 into all that, and you should get 0.5 feet per second squared. So the acceleration is declining with time. All right. So that does it for 87 and 88. Let's do number 90. And we will be done with this assignment. So number 90, we have an astronaut. And this is going to be S of t is negative 27 over 10 t squared plus 27t plus 6. All right, Okay, and part A, we want to find expressions for velocity and acceleration. So velocity is going to be s prime of t. 2 times 27, that'd be negative 54 over 10. T plus 27. Derivative of 27t would be 27. Derivative of 6 is 0. And then a of t, we're going to take the derivative of velocity, so v prime of t. So that would just be negative 54 over 10, which is negative 5.4 feet per second squared. All right, part B says find the time when the rock is at its highest point by finding the time when velocity is equal to 0. All right, let's set negative 54. In fact, let's change that negative 54 over 10 to negative 5.4. It's a little easier for your calculator, right? T plus 27 equals 0. So we have negative 5.4t equals negative 27. So t is negative 27 over negative 5.4. And that is 5 seconds. So nice round number there. And then part C says, or excuse me, what is the height? So that would be position. So s of 5, what's the height at 5 seconds of the rock? So that would be negative 27 over 10. We're going to use the position function times 5 squared plus 27 times 5 plus 6. So if your calculator doesn't betray you, that would be 73.5 feet. And then part C is just asking you to remember your physics. How does the acceleration of the rock compare with the acceleration due to gravity on Earth? Well, gravity on Earth is minus 32 feet per second squared. And then the gravity of the moon is minus 5.4. Okay, so the moon is roughly 1/6 the mass of the Earth. So this the acceleration due to gravity has to do with mass. If you'll divide 32 by 6, you'll probably get pretty close to 5.4, 5.33. So yeah, that makes a lot of sense. All right, that does it for this homework assignment. I'll talk to you next lecture.